question number 1. Everything, the technology just works fine now. I don't know what that first couple of weeks was. Anyway, here we go. So, question number 1. What we're doing, what is this about? Chapter 7 is all about fractions. I know that's kind of bad news, huh? Yeah, thanks. We're in 7.2. Yeah, we're in 7.2. Thank you. I was testing you. Right. 7.2. 7.2 we're in. So, yeah, it's all about fractions. So, it won't be too bad tonight. 7.2 especially is not too bad in section. 7.3 is a little harder. We start getting to the LCDs. Next Monday is the big day. 7. That's why I gave one whole day to that one section instead of 2 sections. Because it's the hardest by far. And that'll be the last section on our first exam. Because that'll be adding, subtracting with different denominators. That's always what's a big pain. Okay, so this in 7.2, it's multiply. All the problems are going to be times or divide. That's pretty easy because you don't have to get common denominators. Do you remember that? For fractions? Let me just give you simple fractions again. So 7.2 is multiplying, dividing. I don't know if you can read. That's pretty scribbly. Multiplying, dividing. So just think about simple fractions. What if I had 2/3 times 5/7, you know? How do you times them? Well, you just go straight, right? You just go 2 times 5, 3 times 7, what's that, 10, 20, you use calculator, done. Nothing more fancy than that. Remember that? So that's all we're doing. There's nothing fancy to do here. If we were adding those, that'd be a lot harder. You'd have to make the denominators the same. That's next week. All right, so we're just multiplying. So you can just go straight. But let me make one more suggestion. What if instead of 2/3 and 5/7, it was 2/3 and 5/9? What could I do in that case when I'm you still could go straight if you want. You could just go, look, it's just 10/27, just straight. Oh wait, there's nothing you can do here. I'm getting confused. I am definitely getting confused. Let me try again. I thought I made a good one. I did not. No, here, let's do this. What if I made it I've got a plan. I do. 2/9 and 3/7. There we go. You see where I'm going, right? So you could go straight like that, but what would be a better... Then you'd have to reduce that, wouldn't you? Which you could do, but what would be quicker? Yeah, cross cancel. So it's not cross multiply. I'm not going to times 3 with 9. I'm going to cancel 3 into 9, huh? It's called cross canceling. When you have an equals in the middle, that's when you cross multiply. When you have a times in the middle, you cross cancel, right? 3, what I'm really doing there is dividing both those by 3, right? That leaves a 1 here. And so what would the final answer be? 1 times 2 is 2. 3 times 7, 21. Which this one would reduce to in the end, right? 221. Same answer. It's just a little bit harder this way because the numbers get bigger. All right, so I said that fast. Let me say it slower and straighter. You can cross-cancel when you're multiplying 2 fractions, and it's quicker. All it is basically early simplification. That's all cross-canceling is. Simplifying early rather than after they're all big numbers. Either way is fine, same answer, easier to cross-cancel right in the beginning. You're really just simplifying, aren't you? You're just saying, hey, these guys are both divisible by 3, right? That's all cross-canceling is simplification. It's just fancy diagonal simplification. You know, just like you would simplify 3 over 9. You would just go divide by 3, 1/3, right? Well, that's what I basically did. 3 went into 9, made 1/3, didn't it? That's all I did. That's all cross-canceling is simplifying at a diagonal angle. You know, that's all it is. All right, let's get back to it. So that's the name of the game in 7.2. Cross-cancel, multiply what's left over. It's pretty quick and easy. So what can I cross-cancel then? On number 1. Yeah, is that big enough? I want to make it bigger. Can you all see that? Maybe I better make it bigger. So 5x over y squared. So number 1, 5x over y squared times 9y over 7x. Okay, yeah. So what can I cross-cancel? X with x. How about that? And then y with one of these y's, leaving y to the first on the bottom, huh? Is that good? So what does that leave? And then the numbers, 5 times 9. Use your calculator if you need to. 45. The bottom, 7 times y, right? Y and 7. Done. Pretty quick, huh? This will be a pretty easy section. So just cross cancel, multiply what's left over. Let's try number 2. So, oh, that's messy. All right, minus 7p to the 5th q. Minus 7p to the 5th q. Over 42p to the 5th q squared. And times q to the 3rd. All right. Yeah. All right. So what are we going to do? Same kind of thing. Hey, what do you do with like a whole number or a whole letter, q to the 3rd power?
You put 1 over 1.
Yeah, over 1. Huh? It's really in the top, isn't it? It's really numerator. So put that over 1. Yeah, so then go ahead and cross cancel anything, or straight up and down cancel. Either way, it's the same thing. Like p to the 5th cancels p to the 5th. Say good. Keep going. I'll let you finish it. And then do the numbers too. Use your calculator. 7 goes into 42, right? But use your calculator there. So 7 goes into 42 6 times. And then q squared. Ready for the q's? There's a lot of different ways you can do it. Probably one of the quickest ways, I just go, look, q squared cancels in, leaving q to the 1st there. Is that okay? So that'll equal, what's left over then? Negative, don't forget that negative sign. Make your negatives big. I would encourage it. Makes it easier to not lose them. And then q and q to the 1st is q squared. Sorry, that's kind of a sloppy q. Q squared. What's on the bottom? 6. Minus q squared over 6. Yeah?
Why wouldn't the q on the top be canceled by the q squared on the bottom the way the p5 cancels?
It could, but you can't do both. So let's go back and do it a different way. You'll get the same answer in the end. So what was that? Q cubed in the front. Good question, Natalia. So everybody hear Natalia's question? So she's saying, why can't we just cancel this guy into this guy, leaving q to the 1st? You totally could. Totally could. That's great. And then I'm not done, because this is still over 1. So anything on the bottom and top that match, you still keep going, right? This is bottom, this is top. So what's going to happen with them now? Right? That q to the 1st will go in here, leaving q squared. Same answer. Isn't that the great thing about math? It doesn't matter your style as long as your logic is solid. I like that about math. It's just truth. I used to write English papers. I never got A's in my English papers. I always got B's. And I get it back, 85. Like, why? What are the 15 points I missed? Tell me the 15 points I did wrong. That's how I always felt. I'm sure I was just an ingrate and they were right. But anyway, I liked straight ahead truth. Yeah?
Mister, what about the negative Q? So we send them to the bottom and we put 1 on top?
Oh, no, that's powers. That's negatives in the power zone. We'll get to those later. Yeah, you remember, that's negatives in the power zone, not negatives in the front. Yeah, later we'll do negatives
like that.
On the 2.
Leave the negative.
That'll make them jump later. Yeah, that's negatives in the power zone.
So that negative on the first beginning, it doesn't go with the negative 7, so it would cancel.
Yeah, it goes with anybody.
Oh,
So it's just there. So think about, to answer, it's a good question. Think about if I had negative 2 times 3. Times 4, maybe. What is that? Negative 24, huh? Would that be different than if I put it on the negative 3 in the middle? Still just negative 24, huh? So you got a bunch of things times and divided. It doesn't matter where the negative is. He's just there.
Oh, so you have to keep it.
Oh, yeah, you can't lose it. If there were 2 negatives, that'd be positive.
Okay.
But if we just have 1 negative, he's just there wherever we want to put him. I can move him to the bottom.
I thought since you canceled out the 7, it would cancel.
No, yeah, well, yeah, so the negative is separate from the 7. Right? So that negative, yeah, is separate. So the 7 itself canceled. So how you could think about it if it helps you, that's like a negative 1 next to the 7. Think about it that way. That's really what it is. Or, I could give you one more way if I haven't given you enough. Just think about negative 7 over 42. What is that? Negative 1/6, huh? The negative is still there because the fraction is negative. That's all we did there. Other questions on that one? Not good? All right. Okay, so number 3. Can you do that one? What are you going to need to do first before you start canceling things on that one? Factor. Here we are again. That's why I said that factoring chapter was so important. So much of what we do in the rest of the course begins with factoring. Here we are again. So you got to factor that 6x plus 6 and factor that 24x plus 24, right? Parentheses, take out the GCF, you know? Do that first, then cancel. Do the GCF factoring on these two. Then cancel. After you've taken out the GCF. And you've already got the answer, so you get it all the way down to a half. So how do I factor 6x plus 6? What's the GCF? Take out the 6. Leaves x plus 1. And then how do you factor 24x plus 24? Take out the 24. We good to there? Now we cross cancel anything that matches top to bottom. So x plus 1 cancels x plus 1. I'm making sense? What else can I cancel here? Yeah, you can go 7 into 14 2 times. Yeah, and then 6 into 24 4 times. And so the answer is 2 over 4, but that reduces to be a half. There we go. That means all this mess is a fancy way to say a half. That's what that means. Is that good? You good with that? Questions? All right, let's try number 4. So number 4 is a couple of factoring problems again, right? Factor top, factor bottom.
So you have to do the GCM first. Which is 6. That would make a lot. Because yeah, it wouldn't make sense with that. So you get rid of GCF. There's no other 6.
Oh no, that's an equal sign.
That's an equal sign.
Okay, because that's
That
what's
must
doing
be
it
wrong.
wrong.
That was my negative signs.
A negative snuck in there.
So you can cancel or you need to? No, yeah. You need to
This is
factor.
how I did this one, and I canceled 2, and then that's how I got 4. So I did it the same way.
Nice. Good job, man.
Yeah.
So factor these guys.
3 terms, so I need to do one small and a big one.
Talk about that. Good question. So let's factor this guy. How do you factor? So how you do it on the factor? We're having the factoring test, a week from Monday. So when you see 2 terms, this is only 2 things, right? What's the only thing we do with 2 terms?
It's a double-double.
It's the double-double, or FL if you want. So it's like the foil with the OI missing, right? It's just the 2 parentheses, X is in the front, 5's in the back, 1 plus, 1 minus, super easy, right? Probably your favorite kind of factoring. Is that good? Okay. And the other stuff I'll just put over here, x plus 1x. Now, the harder one to factor, a little bit harder, is x squared minus 4x minus 5. That's FOIL, isn't it? F-O-I-L, 2 parentheses, x is in the front. What are 2 numbers that can multiply to be 5?
1 and 5.
Yeah, 5 and 1, 1 and 5. Actually, the order doesn't matter in this one because they both just have an X in the front. It only matters when they have different things in the front, like somebody has a 2X and somebody has a regular X or something like that, right? If there's just an X in the front of each parenthesis, it doesn't matter where you put the 1 and the 5. Now, remember how the signs go. I hope this is getting more and more comfortable for you. How do you do the signs?
Middle bigger.
Same.
Yeah, middle, bigger. Sign in the middle, always on the bigger, right? It's the middle that tells you the sign story. So the sign in the middle, goes to the bigger, the 5. Minus there, plus in the 1, right? Plus 1 minus 5 makes minus 4, doesn't it? And they multiply to be negative 5. It's good, huh? Is that okay? Now we're ready to cancel. So what do we cancel? Anything that matches. So x minus 5, x minus 5, x plus 1, x plus 1. We give that to there? So you can cancel straight up and down or diagonal. It doesn't matter. Just top to bottom anywhere. Isn't that good? What's left over? X plus 5 on the top, regular x on the bottom.
How come we can't cancel those two?
Yeah, really good question. So we all good to there? And I want to answer that question. We all good with the factoring and the canceling? See, if you're a good factorer, these won't be hard. It's just the main work is factoring. Yeah. Now, why can't we cancel those x's? It's just a rule. Just don't do it. It's bad. You shouldn't. I'm sorry. I'm just joking around. That's a terrible way to teach or think about mathematics. It's just a rule. No, I hope you know there's actually a logical reason for that. Basically, let me prove to you that it's simply the case. Like, and here's how I would prove it to you. You know, if I was in the middle of the test, rather than just give you this one particular rule, let me help you to figure out a lot of algebra rules for yourself. You want a method by which you can figure out hundreds of rules without any math teacher or math book there to help you. It's a special psychic power. I'm selling the powder for... No, I'm just joking. Sorry. No, it's just tested out with numbers. When I got that, when one of my buddies told me that and I started doing that, that was so helpful. Because there's too many rules in algebra to memorize them all the time. What am I talking about? Let that x be like a 2 or something. And see if you can cancel them out. Just look at real life numbers. Here, let's do that. So if I was looking at this on a test, you know, and I was wondering, oh, can I cancel those x's? I can't remember. There's too many stinking rules in algebra. There are. I would go, okay, well, what if that x was like a 2 or a 1? Something simple, you know, like 2. And I would just think to myself, okay, if that x was a 2, see how this is the same scenario, but I'm putting a number in? Could I cancel those out? Well, what is that thing really, before I do any special math rules, what does that really equal? 7 over 2, right? That's 7 over 2. So if I cancel out those 2's, is it right? Can't do it. See how easy you've got to the truth? That's just not true, is it? That's the beauty of math. It's just truth. And so just put in some numbers and see what's true. You can't cancel those 2's. That would make 7 over 2 become 5. That's not right. 7 over 2 doesn't equal 5. So no, you can't. Now, I'll give you the deeper reasons as well. But do you see how you can get to truth yourself? Just put in a number. That'll help you in a million situations. So anyway, what is the rule? The problem is the plus sign. I think Natalia said that, or somebody said that. That's right. It's the plus sign. If that was times, it would be okay. Let me show you what I mean. If that was times, if I had, let me change the color for clarity here. If I had 2 times 5 instead of plus, over 5. Now, what is that really, aside from any fancy math rules, what does that really equal? 2 times 5, 10 over 2, which is really 5. See how it's okay to cancel the 2's now? It really is 5. See how that holds to the truth? So the problem is the plus. Times, that's fine. Plus, it's not. You can just see it right there. It's just true. Right? Yeah.
So is it only with the plus and the minus sign?
Yeah. So the full orbed rule is, and so I'll give you like something to help you remember it. Pluses and minuses are like glue in algebra. They glue things together, and you can't break the glue bond. It's like shopping at Costco or Sam's Club. You know those warehouse stores? You ever shop there? We have 5 kids. My wife shops at Costco. You buy in bulk. You get like a lot. So you go there to grab one of the milks, right? It's plastic to another one. You can't take your scissors to Costco and cut the plastic and say, thanks, I just want one. You can't do that. It's the whole deal. You buy in bulk, you'll get a cheaper deal. So that's what pluses and minuses are like in algebra. Not times, but pluses and minuses. Pluses and minuses, they glue it together, which means you can't take part of the package unless you buy the whole package, right? You can't, no, I just want the 2. Thanks. No, you can't. It's glued to the 5. But if you're talking times, that's just shopping in Save Mart. Yeah, you can buy just one. See the difference? That's the difference. And why? Because it's true. So we see it with the numbers, right? That's just what's true. So there's the rule. I'll write it out for you. Well, in fact, yeah, here, I'll write it here. So pluses and minuses glue things together, meaning cancel all, meaning both of them, or nothing. You may not cancel just one of 2 things glued, plus or minus, right? I'm sorry, I'm scribbling there at the end. So that is the truth, as we saw with numbers. So 2 things plus or minus, and I'll remind you this as we're going through. When next week we'll talk a lot more about it. We continue to do fractions. So 2 things plus or minus, they're glued together, which means they're a package deal. Buy them all or buy nothing. You can't break that bond. You can't take just one. It's just like shopping at Costco.
Go along with that.
All right, we good with that? But yeah, if you forget that, just test it. Middle of the test, there's so many things to remember. Just pop in a number, and you'll see whether it's okay or not okay. That's always the best thing. All right. I better move on. This will be, if that was too fast, I'm sorry, but I do want to cover more material for you. Now we're dividing. Instead of multiplying. It's hardly different at all. How do you divide? You remember? I bet you remember. What do you do? Yeah, you just flip the one in the right, huh? Just flip the one in the right. Sometimes people call it keep, change, flip. That's a nice little memory device to help, if that helps you. Basically, for dividing, you keep the first one, change the sign in the middle, and flip the one on the right side. Keep, change, flip. Why? Because dividing is upside down multiplying. You know that, huh? You know that 10, just think about numbers. I always go back to simple numbers. You know that 10 divided by 2, which is 5, is the same thing as 10 times what? A half, right? So I'm just showing you that you already know. Dividing is just upside down multiplying, right? Half of 10 is 5, just like 10 divided by 2 is 5. Dividing by 2 or multiplying by the upside down of 2, a half, is the same thing, isn't it? Dividing is just upside down multiplying. You know that. And so that's exactly what we do with this fraction. So I keep the first one. So keep the first one. So 3x to the 7th over 7x. So keep it. Change the middle one. Change it to what? Times. Because multiply is upside down dividing, or whichever way you want to say that. Dividing is upside down multiplying. Flip the one on the right. It's got to be the one on the right you flip, because that's the one you're dividing by. And now that we've changed it, see how we've changed it to a multiply problem? Now you just do the same thing we've been doing on the last 4 problems. Can you take it from there? Now just cross cancel. So keep, change, flip. Whenever you have divide, keep, change, flip. And take it from there.
You don't simplify.
But cross
Oh, you
cancel.
multiply straight up.
Yeah, because it's
14 times 3, this will be the same as 1. 42.
So 7 goes into 14 2 times, right? And 3 goes into 9 3 times. And now, what about the x's? One way it might be easiest is just to take the total x's on the top. Right? How many x's do we have on the top all together? 10, right? 7 and 3. And how many in the bottom all together? 6, because we have 5 and 1, huh? So they're going to cancel, and how many are going to be left over where? 4 on the top, huh? So I'll just go, okay, so just cancel, leaves x to the 4th. So when we're all said and done, we have a 2, x to the 4th on the top, 3 on the bottom, as that answer says. Is that good? Keep, change, flip. Dividing is upside down, multiplying. Keep, change, flip it upside down. I should have put an equals here. All right, so there we go. Is that okay? I'm going to move along. Number 8 there. So that's a divide problem. So keep, change, flip. Keep the first one, change to multiply in the middle, and flip the one on the right, because dividing is upside down, multiply.
So do we do that first before we factor?
Either order, really. So keep, change, flip, and then factor away.
And then we have to factor. So there's 3 terms, we have to do 2 of those parentheses for that one.
Okay, so we need to organize it again. This is 3x plus x plus 2 plus x. This is an order.
Come on. X squared minus 6 minus 10. So compare with those around you. See if you're getting the same answer. So keep, change, flip. So I keep it. Change to multiplication. Flip the one on the right. Okay, now we got a factor, don't we? So this is a FOIL here. When there's 3 terms, it's always FOIL.
But like he said, you cannot do it independent.
So what multiplies to be 2? 1 times 2, doesn't matter what order, they both just have an x in the front. How do the signs go? Sign in the middle, and the bigger, always true, but in fact both of them on this one. Plus 1 plus 2 makes plus 3. Over x minus 4. And then over here, same kind of thing. It's FOIL down here. So it's going to be x minus 4. And this is 2 parentheses. X is in the front. What multiplies to be 10? 2 and 5. Sign in the middle, bigger. On the minus 5 plus 2 makes minus 3, multiplies to be minus 10. Getting quicker and more comfortable with that factoring? Okay, now we're ready to cancel anything that matches. So x plus 2, x plus 2, x minus 4, x minus 4. We're left with x plus 1 over x minus 5. We good? Why can't we cancel those x's?
It's part of the whole.
They're part of a glued package, right? X plus 1 says, I'm a package deal. You either buy all of me or none of me, right? Package deal. So That's it right there. X plus 1 over x minus 5. All right. Questions? There's a little trick to it. So same thing, keep changing. Let me just give you a hint, right? Let me just do the trick part with you right now. This right here should alert you to something we did last time. I mean, we did a lot of things, and it's hard to remember. I don't really expect most of you to remember. But we did do one little thing. It was kind of a small deal. Anybody remember? Like, what's so special about that right there? Yeah, you want the x in the front. When x is subtracted at the back, we never leave them that way. What do? Put a -1 in the front and flip it around. Make this that. You know, that's the same thing. If you were to, let me show you. If I was to distribute that, you see what it would become? -x plus 3, which is the same as 3 minus x. Why is that the same? What sign's in front of the x? Negative. What sign's in front of the x? Negative. What sign's in front of the 3? What sign's in front of the 3? That's the same thing. So this is just another way to say the same thing, but to say it with x in front is going to be way easier for us. So, do you remember that rule? That's going to become especially more important next week. So what am I saying? When x is subtracted at the back, when x is subtracted at the back, factor out -1, -1 and flip it. I called it the turnaround rule. That was just my little name. Turn around rule. So when do you do that? Whenever x is subtracted at the back. That goes for any of these fraction problems. If you've got a piece of the puzzle that has x subtracted at the back, flip it around with a -1 in the front. It's the same thing. It's another way to say the same thing, as we can tell on that example, as I just proved. It's another way to say the same thing, but a way easier way for us.
So don't put the 1 in here.
No, yeah.
Oh, yeah. A -1?
But it's not negative, it's going to be positive now. It's going to be x.
That's totally good.
X minus 3. And this time it's minus 3.
Oh, so I will like
At
that's
this
how I
time,
got it.
yeah, x is positive.
No, it's, well, yeah, but you do it in parentheses.
So turn that one around and then keep change flip, right? It's a divide problem, so we got to do the keep change flip thing yet again, right? Keep change flip.
Or flip the order. But I rewrite it.
And then now we're going to factor.
So now.
And then that x squared minus 9 needs to be factored, huh?
This is
Yeah. So it's 1 plus 1 is
That's a
negative.
double. You need the 3 systems like it is, or how do you just go by 1, no? Say x plus 1 times 26. No, we should do like it is.
So keep change
How you can factor 26?
flip.
Just put
So I keep it,
no.
change to times, and flip the one on the right. Good to there. And then you got to factor that x squared minus 9. So let me come in here. You know how to factor that thing.
Like 36 times
X minus 3, x plus 3, like that. And then we cross cancel anything we can. X minus, see, that's why it's so helpful. We've turned that around so now we can see the match, you see? That's why we needed to do that. Otherwise, we wouldn't have seen that as the same thing. Cancel those x minus 1s. Anything else we can cancel? Yes, 6 goes into 36 6 times. And this x can cancel that x. Can I cancel just that x, though? What about, isn't it glued to the y? No, there's no plus or minus, is it? This is shopping at Save Mart. That's fine. You can buy just one. They're not plus or minus. They're not glued. Fine. See the difference? So, okay, what do we got left then? We've got x plus 3 in parentheses on the top. We got a y. We've got, what, a minus 6? Yeah, because it's minus 1 times 6. There we go. Yeah.
About where the y should be. It could be like that, like after the parentheses, or should it be in front?
Yeah, either one. Yeah, so if they put the y in the front, that's the same thing. Yeah, because the order of multiplying never matters. Just think about numbers. 2 times 3 is 6. 3 times 2 is 6, huh? So parenthesis y or y parenthesis, it's all the same thing. Letters are just numbers I don't currently know. So whatever's true of numbers is true of letters. Yeah, good question. Order doesn't matter. Hey, how about the minus sign? How about another question? Could I put that minus sign anywhere else?
Yes.
Could I put it in the front?
Yes.
In the top? Yeah, it's all the same, right? Multiple choice test, you'll know that, right? You know, if you had it this way, and like option C had the minus in the top, say. Like that. You'd grab it. That's the same. It's another way to say the same thing, isn't it? Or what if they distributed it in? What if they said minus xy minus 3y over 6? That's the same thing also. They just multiplied it in. Are you okay with that? Those are all the same. They're all the same.
X, Y plus 3Y.
All these are the same. See that?
So it's okay to do like XY plus 3Y over negative 6.
Yep, that's the same too. Yep. Yeah, you could leave the y parked out here, or you could distribute him in. It's all the same. It's all the same.
It's kind of like those ones we did last week with the 4.
Yeah, with the 4 options. Exactly. It sure is. Is that good? You comfortable with that on the multiple choice? Yeah.
So I'm lost where this negative 1 and then the parentheses equals the same as the other one.
You wanted the parentheses.
Yeah.
So you mean, are you okay to hear, you mean? Or are you wondering how I got here or how I got
I'm
there?
wondering how you canceled x with 3
Mm-hmm.
with that one with a negative in front of it. How are
Because
those
this
two?
one, you wanted
So I canceled these guys
to
out.
in the front.
X minus 3, x minus 3. The negative one is separate from that.
Okay,
Yeah, so he's just separated.
So that's why it's not.
got it.
So he's just sitting there, and then he just multiplied the 6 that was also left over. Negative 1 times 6 would be negative 6.
Okay, I was thinking those were a unit. Okay.
Yeah, things are only a unit if they have what between them? Pluses and minuses, right? So that's good thinking as far as when, worried about when things should be units. When are they built? Pluses and minuses. So what's between the minus 1 and the parentheses? Nothing. So they're separate. That means they're save marked, right? You with me? Only pluses and minuses glue things together. Make them a package deal.
It can be whatever.
All those are the same. All right.